Okay, so most important, we know, of course, R squared is the first indicator, let's say, whether we have a good model or not, but even having a very low R squared, we shouldn't drop it, because we have more than only R squared as a measure for the quality of the model, which is p-value, and that's the most important one. Yeah? P-value is, at the end, a value which should be low enough in order to confirm our result. So if you have a p-value above 10%, which is 0.1, then in this case you shouldn't think that your model is, or this relationship is significant. In our case, we have a great p-values. So for both, for the intercept and tax rate, we have a p-value below 0.05. Okay? So at the so-called 5% significant level, we could have also 1% significant level. If I would have here additionally 0, then it would be below 1%. Yeah? For sure. And in some cases, especially as far as I know in marketing, a significant level of 10% is appropriate. I would say 10% is already a little bit problematic. Yeah? As I mentioned, interpretation of intercept is not sensible in every case. So, for actually, I would say that I don't pay a lot of attention to the p-value of this intercept. Yeah, but it's nice that it's 0.00. Yeah, so it means that indeed having a tax rate of 0, I should expect the FDI of 83% of GDP. But what is, of course, the variable of interest, and by that also my coefficient of interest, is this coefficient for x for my tax rate of minus 1.71. Now, a p-value is also, of course, correlated, because it's a measure for the quality, is correlated with the interval. Here in this case, you have an interval of 95%. Interpretation would be like, with a probability of 95%, or 95% of your outcome will be within this interval. Okay? And if this interval begins, for example, with the negative value, yeah, and ends with a positive one, what do you think? A p-value will be a lower one or rather higher? Do you have any results with a p-value above 0.1? Be honest. Yeah?
I have 0.14.
You have 0.14 for the intercept, or
The p-value.
yeah, but for the intercept or for the tax rate?
For the tax rate.
For the tax rate, you have a 0.14. I'm pretty sure that your lower 95% value for the interval is a negative one.
Yeah.
But the second one is a positive one.
Yeah.
Yes! It means that in this case, 95% of your results, yeah, with a probability of 95%, your prediction is somewhere between minus and plus. If we have an interval beginning with a negative value, yeah, and ending with a positive one, do we have any relationship? What do you think? What would it mean? That in some of my 95% of results, my prediction is there is a negative relationship between the tax rate and FDI, but sometimes it's a positive. So, and the first or most important thing we try to figure out with a regression is, of course, whether we have a relationship and whether this relationship is a positive or negative one. It's not possible to say, yes, and sometimes it's a positive one, sometimes it's a negative one. There's not a sensible result. So that's why the p-value is strongly linked to the interval. If you have a high p-value, it's confirmed by your interval that your interval would be an interval between a negative and positive value. If your p-value, that's a question also, if your p-value is low, then you should observe for the intercept, if a positive value, your interval should begin with a positive value and end with a positive value. And of course, if the spread is very low, so if interval is close to your prediction, it's even better, because it means that you don't have a strong deviation within your 95% probability. Yeah, the outcome. Yeah.
I have like for the p-value 0.07, and still have for the lower value minus 2.9, and for the upper value 0.1. So it's still the case that it's not feasible, right? Okay.
So it's actually support for that this significant level of 10% is not really good enough.
What were you? So in your case, what was the lower and upper? I mean, you covered this with the.
So no, it's not the case. What is lower?
Yeah.
Okay, you mean here the interval. I guess I have this on my slide here. So that's the result between 50 and 117 and -3 and still minus.
Okay.
But as you can see, if you would make a prediction, you have to be very careful. And if you would say, okay, it's -1.7, but still 95% of your results are somewhere between -3.1, it would mean for a country that FDI could drop by 3.1%, but it could be that FDI will drop by 0.26% of GDP, which is of course a significant difference between this two. Yeah. So but still, it's just strongly supported. We have a negative relationship. The first important result, but of course, today it's not enough. Today you have to deliver some magnitude. So, okay, it's nice to know that we have a negative correlation, but what I should know in order to make a decision, I need to know what kind of a change I should expect. Yeah, and so that's why the prediction and the interpretation of this prediction is very important. It's not today, it's not enough. Maybe 10 years ago, it was nice to have to say, okay, it is a negative correlation. We have a support for that. We are great. Yeah. Today is the question. Okay, nice, but what is the magnitude? What is the value for this change? I should maybe consider for my decision. Yeah. So in your case, it would be a support for a significant level of 10%. That's why what I meant is that we should up to 5%. It's a safe, significant level we should consider. Yeah. So and then what we should know, of course, that our simple model was like y-intercept tax rate. That's all. And we should, of course, implement some more data in order to improve this model. So that's why we would go toward a multiple regression. And here we would use more than only one independent value. And here, it's a nice video on that. As a homework, let's say, here you should be careful about the multicollinearity between two variables. And the other group created a nice example for that. If we would like to check or predict the number of smartphones we would like or we will maybe sell in a particular country. So let's say Apple would like to know what could they expect in order to number for a certain country.